part 2 of classifying matter, we're going to talk about the properties of matter. So properties of matter really need to be broken down into two distinct categories, chemical properties and physical properties. So chemical properties are basically how is something going to react. So it's our ability to predict what's going to happen and the properties that are associated with that reaction. So when something undergoes a change, we need to be able to describe what it was like before and what it was like after, and then we also need to describe what's going on during the reaction. The opposite of that would be physical properties. So physical properties are just what you observe. So if you're looking at another person, you can observe maybe they have brown hair, maybe they have green eyes, maybe they're wearing a polo shirt. Those would all be physical properties of the person that you're looking at. So you can observe and measure those properties without actually changing the composition of the matter, which if you have chemical properties, you would be changing the composition of the matter because you're talking about reactions. So there's the main distinction between the two. So physical properties, we're just going to be able to observe and describe what that matter looks like, and it's based on what are called intrinsic properties. Intrinsic properties do not depend on how much of the sample you have. As an example, if I have 10 pounds of copper, the properties of that copper are going to be exactly the same as if I had 2 pounds of copper. So the amount that I have does not control the intrinsic properties. So it's independent of the quantity. Examples of that would be color, boiling point, melting point, density, odor, and texture. These cannot be changed without actually changing the substance. As another example, in the last video we saw solid sodium being added to gaseous chlorine. That solid sodium looks like a metal. So I would say that it has a silver color, it has a specific boiling point, melting point, it has a specific density, it doesn't have an odor, and the texture would be smooth. On the other hand, the chlorine gas, which is another element on the periodic table, is completely different. It was gaseous, it had a yellow color, it would have an odor of chlorine, it wouldn't have a texture because it's gaseous, so they're completely different intrinsic properties, and that's based on what it's made up of, or the elemental substances that you're dealing with. So here are some examples. So bromine is one of the only two naturally occurring liquids on the periodic table. It has a natural red color. It has a fairly low boiling point, which means that if you were to put it on a stove and crank up the heat to 137 degrees Fahrenheit, it would turn into vapor, and it has a very low melting point. So the reason it's a liquid at room temperature is because it has such a low melting point. So if you think about it, if you take an ice cube out of the fridge, you leave it on the counter, room temperature, it's going to melt. That's what melting point means. So if I have solid bromine and it was at negative 20 degrees Fahrenheit, it would be solid. Once it reaches that negative 19 degrees Fahrenheit, it's going to start to transform into a liquid. It has a pretty low density at 3.1. And bromine it's kind of a funky smell. It has like a bleach-like odor to it. It's very a noxious gas. So another example of intrinsic properties of silver, which is a metal. It's a very common metal. It's made, a lot of people use it for jewelry. Ironically enough, you would say that the color is silver. It has a very high boiling point and very high melting points. If you can compare the difference between the bromine melting point, boiling point, and silver, it's extremely different. So the boiling point of silver is almost 4,000 degrees Fahrenheit. That's extremely hot. That's how hot it would have to be in order to boil it. Melting point, 1763 degrees Fahrenheit, also very high. So if I want to turn solid silver into liquid silver, I would have to crank the heat up to 1763 degrees Fahrenheit. Very hot. It has a pretty heavy density. It's about 3 times as dense as the bromine or chlorine. It has a 9.3 grams per cubic centimeter density, and it doesn't have an odor. It's a solid metal. Chlorine gas, it's in the gaseous form, so I purposely picked 3 elements on the periodic table that were in different states of matter so you can compare They have different states of matter. They have completely different properties to them because of that. It has a very low melting point, negative 150 degrees Fahrenheit. That's extremely low. Boiling point is also very low, negative 29. That's the reason why it's a gas at room temperature. It has a yellow color, and chlorine smells like chlorine. It has kind of a pool odor to it. So all different intrinsic properties that cannot be changed no matter how much of the substance you have. The opposite of intrinsic property is an extrinsic property. Extrinsic property is just how much do you have, which is the exact opposite of the intrinsic. So it depends on the quantity of the sample, so the shape and the size could change, the mass, the volume, so how much space it takes up, that's volume. That's all dependent on the quantity, which is extrinsic. So the object itself does not change if an extrinsic property changes, meaning, again, the copper situation, I could have 10 grams of copper, I could have 2 grams of copper. It's still copper. The only thing that changed is the amount that I had and the amount of space that it takes up. So that's the end of this section, part 2, and our next section will be talking about separating mixtures based on their properties.